Hello, everybody. It's Mr. Brumleve here, and I would like to run you through a quick review of the common mistakes I saw on the practice midterm. So hopefully throughout this little presentation, you get to bring your confidence from right around here and bring it on up to here. Wait a minute, he doesn't look that confident. He just looks like I told him to put thumbs up. All right, let's see. All right, a little bit better. Not as confident as I want. He looks like he's faking it. And what about, all right, yeah, no, he looks confident. Dapper scarf. He looks ready. Confidence. Let's go. So according to table F, now I want you to remember something. We're going to need to have our reference tables out for both the midterm and the practice midterm, as well as these questions. So take a moment, take out your reference table, or you could go to the classroom and use the one that I added to the Google Drive. Now, according to table F, which ions will combine with sulfates, SO4 with a charge of 2-, to form an insoluble compound? We're going to need table F. We take a look. Now, remember, we're trying to form an insoluble compound. That's the key word here. So we go down the list of soluble compounds, and we find sulfates right here at the bottom. And then we're going to go through our answer choices, and if any of the ions are listed here, we know that it's going to be an insoluble compound. There she is. Ca2+ ions are going to make sulfates, SO4, which are right here, insoluble because they're listed under the exceptions. So if something is soluble, it's listed over here, and if an exception is listed with it. So if we have calcium along with SO4, it's going to be insoluble. That's what table F is describing to us. So what is the gram formula mass of NH4 on the outside the parentheses? That means we're multiplying this whole thing by 2. Now, in a formula, that means that there's going to be NH4 on one side of this CO3, and on the other side, there's going to be another NH4. So we quickly are going to do the gram formula mass, which is just us adding up all of these elements in the molecule together. So first, let's take a look. We got our gram formula mass, the total mass of all elements in the molecule, gram per mole. That's the unit we're going to use for this, grams per mole, because that's what we have on the periodic tables. All those masses are basically grams per mole. Nitrogen, we look at the reference table and we find it has a mass of 14. We are going to say that each nitrogen times 1 is going to be 14. But when we look at this formula over here, we're going to see that there's not just one nitrogen here. Because on the outside of the parentheses, we have this 2, we need to multiply that one nitrogen by 2. So just like in math, we're using distribution, and it's basic algebra. We're multiplying that one nitrogen times 2, so we have 2 nitrogen. And now that we have 2 nitrogen, if each nitrogen has a mass of 14, we get a total of 28. Next, hydrogen. 1 hydrogen is 1 gram per mole. Inside the parentheses, we have 4 hydrogen. But in this case, we need to make sure we're looking at the outside the parentheses again. So we don't just have 4 hydrogen total in this molecule. We have 8 of them because we needed to look at that 4 hydrogen inside the parentheses, and we distribute the 2. We have 8 hydrogen total right here. And 8 times 1, which is the mass. So if we have 8 of them lined up and each one weighs or has a mass of 1 gram per mole, the total is going to be 8 grams per mole since there's 8 of them. Carbon, we look at the reference table. It has a mass of 12. We multiply it by 1 because there's only 1 carbon here. There's no parentheses, just 1 carbon. We come out with 12 carbon for 12 mass for the amount of carbon. Now, oxygen, we have a mass of 16 grams per mole. We multiply that 16 by 3 because when we look at the formula here, oxygen will have 3 of them. And so we get 48. What's the total when we add all these up? Because that's going to be our answer for grams per mole. The total is going to be 96 grams per mole. Next question, number 3. The total number of moles represented in 40 grams of calcium, carbon, and 3 oxygen, calcium carbonate. Let's take a look at table T for our formula. Wait, where on earth is our mole formula, people? Let's go. There it is. There's our mole formula. I thought it could hide from us. So the number of moles is going to be equal to the given mass over the gram formula mass. The given mass is the mass amount they give to you in the formula right there. And the gram formula mass is the total mass of the whole molecule here. So we need to do exactly what we did in the previous problem and figure out gram formula mass for calcium carbonate. First, though, let's write down the given mass that they give us in the problem. It is 40 grams. It's given to us right there in the question. We have 40 grams of it. Next, we got to figure out the gram formula mass. So we set up our table again. And here we have calcium. Its mass of 40. We only have 1 calcium in the molecule. So number of 1. And the total mass is going to be 40 because we only have 1. Carbon, mass of 12. Only have 1 of them. 12 total. Oxygen, 16 mass. We have 3 of them. It's going to be 48 total mass. So what is the total gram formula mass here? Put it in your calculator. Yep, you're going to come out with 100 grams per mole. Now we need to set up our formula for number of moles. So we put our given mass, 40 grams, over 100 grams per mole, our gram formula mass. We put them over each other down here, 40 grams over 100 grams per mole. Now I want you to remember these grams, because we're dividing, there's a grams on the bottom, there's a grams on the top. They are going to divide out from each other because we have 1 in the quotient down here. We're only going to be left with moles. So what do you get when you divide 40 by 100? You're pretty much just moving the decimal place. You're going to get 0.4 moles. Hope that made sense. If it doesn't, leave me a comment, please. Number 4, what is the percent composition by mass of nitrogen in NH4NO3? Here is my issue. Let's start this up. We have a nitrogen here and we have a nitrogen here. We're trying to find the percent composition by mass of nitrogen. So this is pretty much me saying like, okay, we're gonna weigh a bucket of shoes. There's going to be Nike shoes in there and there's going to be Reebok shoes in there. I want you to tell me what percent the Reebok shoes weigh in the bucket. So we would need to take out all the shoes from the bucket and count them all up. So let's take a look. Nitrogen, we got 2 of them. So first, we're going to need to look at our percent composition formula. We're going to take the mass of the part and divide it by the mass of the whole. Now, the big thing here is you can't forget we need to multiply by 100 because this is a percent problem. And just like in your math class, when you divide one part by the whole, you're going to get a decimal. To make that decimal into a percent, you got to multiply by 100. So first, the mass of the part. We're going to take a look at nitrogen in our formula, NH4NO3. How many nitrogens do we have? We got 2. So each nitrogen has a mass of 14 grams per mole. And when you multiply them by 2, it equals 28 grams per mole. Mass of the whole molecule. So this time, it's just the gram formula mass again. That's all we're doing. So let's set up that table again, which I noticed a lot of people had issues with when we were doing it. So you set up the whole table, nitrogen, hydrogen, oxygen. Those are the 3 different elements we see in our molecule here. And we list the mass: nitrogen 14, hydrogen 1, oxygen of 16. And you notice for most of the practice midterm, I was using the same elements over and over. This way it was easier for you to reuse the same numbers. Now, when we look at our molecule, we have 2 nitrogen, we have 4 hydrogen, and we have 3 oxygen. So we multiply across 14 times 2, 28. That's the total mass of nitrogen. We figured that out up here. Hydrogen, each one weighs 1. Now we multiply that 1 by the 4 hydrogen we have in the molecule, because we have that little subscript there, 4. So we have 4 hydrogen multiplied by 4. Oxygen, mass of 16. We have 3 of them according to the molecule. So times 3. And we get 48. Add all of these up. What do you get as a gram formula mass? Gram formula mass is going to be 80 grams per mole. Now we need to set up our formula here, the mass of the part, the nitrogen, over the mass of the whole. You're going to get 28 grams per mole over 80 grams per mole. The units are going to cancel out here because we got grams per mole on top, we got grams per mole on the bottom. Now we can do, wait a minute, what did I forget here? Yep, I forgot to be multiplying it by 100 because we're doing a percent composition of nitrogen. So percent composition of nitrogen, when we divide it, is going to be 0.35 times 100. And that means we move the decimal place over twice since we're multiplying by 100. And you get 35%. So nitrogen is going to be 35% of that molecule. A little bit over a third. Next up, I have an announcement. Mr. Powell's midterm, it's still open today. So I'm going to need for you to go and give it your best. And may you have a good chemistry test. But we still have one more problem to do. So how many total moles of KNO3 must be dissolved in water to make 4 liters of a 2 molar solution? We're going to have to use table T here to get our molarity equation. So make sure you're doing that. Let's take a look. There it is. It's underneath concentration. And the word molarity is what we're using. So molarity is going to be the strength of a solution. So we are going to need to have the moles of the solute over the liters of solution. Let's first list out the knowns that we have. What do we have for the molarity of the solution? Yeah, we have 2.0 m. How many liters of solution do we have? We got 4 liters. And what's going to be our X here? It's going to be the moles of the solute. That's what we're trying to find here. The total moles of KNO3 to be dissolved in the water. So let's set up our formula. It's going to be 2m is equal to X over 4 liters. We quickly do our little cross multiplication because we need to get X to be by itself, just like algebra in math class. So we take our 4 liters, we multiply it on both sides. On the right-hand side, over here, it's going to cancel out, leaving X by itself. Over here, we're going to be multiplying 4 liters by 2 molar. We end up with 8m times L. And according to our formula up here, molarity is equal to moles of solute over liters of solution. So when we multiply molarity times liters, it basically equals moles. So X is equal to 8 moles. That's our final answer. So I hope this helped everyone. Please let me know in a comment if you need any additional assistance. Thank you very much, and I hope you have a wonderful day.